Hey, welcome to the Chapter 1 test review. Just some things that we've talked about over the course of Chapter 1, things I need you to remember that can maybe help you out. We start off with some evaluations where we're plugging numbers in, right? So we know that we're going to take this -3 right here, and I'm going to plug it in for that x right there. So we're going to say -2 times -3 squared plus 5. Remember though, when you're putting into the calculator, I would really use parentheses, okay? So I'm going to write this a little bit better so it's a little bit neater. If I'm punching in the calculator, I'm punching in -2 parentheses -3 squared plus 5. So I'm going to come in here and we're going to -2 parentheses -3, close the parentheses, squared plus 5. And the answer is -13. Okay, same thing, -3 times x minus 2 times y. So we're going to clear -3 parentheses plus 2 parentheses. I'll come back here. I'll try and figure out what we're punching in. -3 times 5, -2 times -3. That should be a negative right there, so I'm going to change that to a minus. And the answer is -9. Okay, so if you use parentheses around there, you will find out that you tend to get the answer correct more often. Rational versus irrational number. Okay, fractions versus not. I don't want to say not because those are irrational numbers. Rational numbers are fractions. So rational numbers are fractions, integers, decimals that end, decimals that repeat. Okay, so fractions would be like 3/2, -2/13. Integers are -5, 0, 3. Decimals that end or terminate. I think they use the word terminate in Alex. So probably on the test it says terminate. So 0.25, notice how that one ends. 0.187. Or decimals that repeat. 0.2 repeating. 0.353535 with the 3 dots. It means it goes on forever, but you can see there's kind of a pattern there of 35, 35, 35. Irrational numbers are all the others. Okay, square root of 2, 1.41495. Pi, 3.14159, ... By the way, back on here, you see you got a square root of 2 is irrational. But if I have the square root of 9, that really equals 3. So even though it's a square root, square roots can be rational if they're integers when you take the square root, okay? Make sure you know how to do that. There's going to be one problem there where you have to justify your solutions. So we're going to subtract 5 from both sides. And that's going to be called the subtraction property of equality. And the list will be there, you just got to pick which one it is, okay? That ends up being (3x equals -13). When I get a 0 there, that's called a simplify. So what do I have? I got 3x equals -13. Okay, I'm going to divide by 3. That's division property of equality. And if I end up with x equals negative 13 over 3, that is called simplify. Okay, notice I worked with the plus 5 first. We always get rid of the addition subtraction first. Okay, just a couple reminders here when you see some things. Okay, if I have w over 5, okay, remember this is w divided by 5 equals 8. And you undo by multiplying. So I need to multiply by 5 on both sides. Okay, 5 on top, 5 on bottom cancels. That leaves me with w equals 40. Okay, so just be aware of that. When you have a fraction like that with a variable in it, that's a division problem. You undo by multiplication. I'm going to work with the minus 6 first, then the negative 2 times. So we're going to add 6. So I have negative 2w equals 23. I'm going to divide by negative 2. And we're going to end up with w equals negative 23 over 2, which is the same thing as negative 12.5. And you'll see in ALEKS, it's okay to have fractions. They're probably not going to happen that way in ALEKS, but just to be aware. Absolute value, we need to have two equations. Okay, and I want to isolate the absolute value of w. So I'm going to divide by 2. So I get the absolute value of w equals 9.5. Okay, and then remember, the absolute value of 9.5 equals 9.5, and the absolute value of negative 9.5 equals 9.5. So that means that this thing here, inside the absolute value, could be 9.5 or negative 9.5, and we still get 9.5 as an answer. Okay, so therefore w equals 9.5, negative 9.5. Again, we're going to divide by negative 2. Absolute value of w minus 4 equals 3. We're going to say w minus 4 equals 3. W minus 4 equals negative 3. Okay, so note that we have the negative equation right here. We're going to add 4. I'm going to add 4 here. We're going to end up with w equals 7 and w equals 1. Solving inequalities, just like solving regular. So we're going to work on that negative 5 first by adding 5. Negative 3x less than 13. Okay, I'm going to divide by negative 3. So I have x. I've got negative 13 over 3. And we have to change the direction of the arrow. Okay, next here, I'm going to add 4. x over 2 greater than or equal to 11. I'm going to multiply by 2 on both sides because I want to cancel that divide by 2. So my answer becomes x greater than or equal to 22. By the way, on a number line, 22 would be right there. We're going to close that circle. And the reason why we close that circle is because of that negative sign right there. Okay? And then I want all the answers that are bigger than 22. This one, you'd have negative 13 over 3, open circle, arrow that way. Okay, we're going to add 10 to everything. So negative 7 plus 10 is 3, less than or equal to 3 times x, less than or equal to 24. Okay, then I'm going to divide by 3. Divide everything by 3, and I'm going to have 1 less than or equal to x less than or equal to 8. And x is between 1 and 8, so my graph would look like that. Remember and or. So we got 3 and 6. I'm going to close the circle off because of that equal sign. I'm going to leave that circle open because there's not an equal sign. And remember absolute value. 4x plus 6 less than or equal to 14. This is an and problem. And 4x plus 6 greater than or equal to a negative 14. So I'm going to subtract 6. I get 4x less than or equal to 14 minus 6 is 8. X is less than or equal to 2. 4x greater than or equal to negative 20. Divide by 4. X greater than or equal to negative 5. When I put that on the number line, there's my negative 5. There's my 2. Okay. If that problem would have been 4x plus 6 less than or equal, I'm sorry, greater than or equal to, that would be an or problem. So we would end up with x is less than or equal to negative 5, or x is greater than or equal to positive 2. Okay, this is review chapter 1.